Hello everyone, welcome to our sessions on how DBS scales on DevOps practices via internal built self-service platform. Just a quick introduction of ourselves. My name is Jigsun and I'm with the bank for 8 years and leading a team of enterprise system services looking after managed system supports of private and public cloud. With me is Edwin, who is leading a team of infrastructure development, automation, including technology marketplace, which we're going to cover later on in this presentation. Let me give you a brief introduction of DBS Bank for now. Right, the world was changing around us. Right, the platform giants such as Alibaba, Tencent are expanding their footprint globally. Fintech startups were unbundling the bank by reimagining the small and focused area of banking. They were doing it cheaper, faster, and better. Hence, it is important for the bank, right, to weigh cost versus efficiency, to scale up and increase our cadence. And with Singapore and Hong Kong as our core market at the moment, and fast-growing presence of the Asian market, we scale up efficiency across the market and acquire new customers without adding up massive infrastructure and increase operational costs. How are we going to do that, right? How we execute our digital transformation, right? We decide to embrace based on 3 priorities, right? Be digital to the core. Right. This means rethinking our technology architecture and reorientating our technology stacks. Embedding ourselves right on customer journey and reimagine the job to be done and make banking invisible. And then to think like a 20,000 staff startup and make it nimble and agile. But what does it take to make it as a 29,000 startup? Right, we envision ourselves to be a startup such as these 29,000 people, right? To be all customer obsessed and agility of this context, whereby we focus on our internal customer and the agility to deliver the infrastructure, right, to accelerate the value to the business. Today, I'm going to I'll be talking on how to be digital to the core, right? How to enable us, right? DBS, right? Being the D in this Gandalf mission that we have. We went very deep and started to look at how our companies operate, how this company here operates, and how the engineer system, how do they do their journey thinking? How do they constantly learn, right? How does Netflix use the data? How does Amazon scale? And how would we taken to be the D in this Gandalf journey? So this is where we have the DBS logo. In the last 8 years, right, we have undertaken quite a lot of transformation and automation, starting to define standard builds and configuration management. We also done a lot of automation, server management, and deployment. Eventually, we went in to provide the user with a single pane of glass instead of different portal. Right, we launched them all onto our platform, and we call it Technology Marketplace. We enhance our capability, right, by providing self-services to the app team, to the log-tech LOB technology people, so that they are able to do some administrative work themselves without the need of a privileged access to. And more recently, right, we provide auto-healing of security setting to what the server that they are owning.
So the underlying process to provide infrastructure components increases in complexity as time goes by. This leads to having onerous interfaces and with users having to engage and coordinate across multiple touch points, resulting in slippage in delivery and overall a cumbersome user experience. Some of the challenges we have are tasks are run manually by administrators and the method of implementation varies from admin to admin. This is prone to error, resulting to reworks and delays in delivery. There is also a high possibility that non-standard implementations can introduce security risks and non-compliance. Furthermore, admins are required to develop applications for service consumption. However, they lack the necessary coding experience. Another big challenge is the complex process to provision and manage IT components. To quantify, the average number of portals that applications team have to know and interact with is more than 20. The number of forms to be raised is in the 30s, with a total of over 1,400 form fields to be filled in. There are 8 unique IT towers to engage with for support and information in case they run into problems. So all in all, the average turnaround time for task execution is in the range of 2 to 3 days, depending on the component and the complexity of the request. Overall, it's not a joyful experience for developers and operations team. With these challenges, we have mapped an approach on how we can address these issues and improve the manner of delivering our products and services to the application team with scalability in mind. Our strategy is to abstract the underlying complex processes and interactions into a unified portal with automation and orchestration at the heart of it. This translates to simplifying and optimizing form inputs, asking as little as possible information from the users, and making use of available data to fill in the rest. Providing an onboarding solution that doesn't require administrator to do development work or coding, and standardizing building blocks for consistent delivery of infrastructure components. On top of that, automating executions of repetitive tasks using enterprise system management tools, third-party APIs, and custom scripts, and developing a single-page application that integrates IT products and services. All of this will allow us to provide a dynamic platform where IT products and services can be consumed and managed as and when needed. Technology Marketplace is a single pane of glass that bridges the underlying infrastructure and the internal processes to the consumers and provides a means to consume on-premise services, and infrastructure products through self-service. So in this framework, you can see that the technology marketplace lies in between the end users and the underlying infrastructures, and how products and services are consumed is through the producers onboarding its service through our content management system. This capability, the content management system, will allow IT administrators or system administrators to offer their services to the consumers either through the self-service capability or through an application programmatic interfaces. So the underlying infrastructures that are being abstracted can either be a compute, a database, storage, a network, and even software. We have three main categories within the self-service portal where tasks or activities are grouped. They are the build, run, and manage. Build is for provisioning infrastructure component. Run is for managing those components that have been built. And manage are those governance areas that underpins these components. Here's how our technology marketplace looks like. We have the landing page on the left that gives user an idea what products and services are available. Keep tab of what's new and used for general navigation. On the right, we have three sample pages corresponding to the three main categories in Marketplace. The build pages, as I mentioned earlier, is for requesting infrastructure as a service consumable. And in this case, in the screenshot, you can see that it's for SSL certificates. The run pages for managing those instances are simply run books for executing operations works or administrative tasks. And in this case, you can see it's for the network concerning Route 53. On the manage page is used for governance areas that underpins the instance, including its life cycle. So in this case, on the screenshot, you can see that it's for onboarding of virtual machines. There are currently 175 products and services available in the technology marketplace, but I will only be focusing on two specific applications that scaled our DevOps by providing self-service capability to users. From a system management perspective, we have AppSys, which is our application self-service portal, and for security configuration management perspective, we have SecureSys. Both applications are used across 6 priority markets in Asia and support 4 of our major platforms and use Puppet for the underlying automation. We have put enormous efforts on automating the end-to-end delivery of infrastructure components, specifically on the compute side. We have improved our inception, solutioning, and design process. We have brought down the provisioning time through the use of standard builds, and we have streamlined our infrastructure readiness check. including security hardening. Infrastructure delivery and setup was at our fastest, so we thought. We have reduced the overall turnaround time from months to weeks. However, we are still seeing bottlenecks and delays in application delivery after the server is handed over to application teams. And upon further investigation, we found out that there are still dependencies with administrators as tasks for their specific setup requires elevated privileges. Things like adding storage or creating and extending file system for their applications, setting system parameters, performance and tuning, installation of software, or even server reboot. Server requests were on the rise, and the more projects that are initiated, the more requests there are. Depending on the complexity of the task requested, and more importantly, the availability of the administrator, it can take up to weeks to complete the application setup or the infrastructure. Now we have a goal, and that is to allow for this task to be executed instantaneously without the need for system administrators. We want to empower the application team to carry out this task whenever they need to. That drove the development of the application self-service portal, or APSIS as we know it internally. Based on the data that we have analyzed, the task requested can be categorized into four broad areas, namely file system services, which mainly deals with storage and file systems, ID management services for ID groups and management of password vaults, system services including OS configuration, services and restarts, and software services that manages installations. All the tasks are represented by a card within the application, and each card is broken down into atomic or basic tasks. Card can have one or multiple atomic tasks to fulfill the desired outcome. Each of these tasks are wrapped within a Puppet task and executed on the endpoint via a custom orchestrator. This custom orchestrator is an in-house developed engine that ensures that tasks are executed correctly and serves as a middleware to the self-service portal. We have put in controls into place to ensure that only allowed users can trigger task execution. Task executions can only be requested for the servers owned and managed by the users. Only allowed tasks are executed. Task executions are duly authorized, and then task executions are logged to ensure that all activities can be tracked and audited. The main automation engine that has been used for this application is Puppet. Execution of tasks are now in minutes. As a result, tasks that took weeks to complete are now completed in days. Security configuration management ensures that the desired configuration is observed and enforced on infrastructure components, including operating system, database, middleware, and software. One of our challenges is that as the server population increase, the need for the administrator to ensure that these configurations are observed and enforced also increases. We have here the process of how we are doing security configuration management in the bank. We start off with a policy review, and then that policy review is translated into a code and deployed to endpoints. On each of the endpoints, we perform scanning and present whatever we have scanned through a report. If there are any changes or deviations from the baseline values, we are doing the fixing of the drift, and if a permanent deviation is requested, do a deviation management. So before, all of these are run manually. So they start off by coding the policies using native scripting, depending on the OS and the platform. Then these scripts are copied over to the machine individually through either a secure copy or a secure file transfer. On each machine, again, they will set up a cron or a scheduled task to execute the script. And after that, aggregations are done outside of this process manually and sent to the respective technology teams. Fixes are carried out manually by the system administrator whenever they have found any deviations. And it's a complex process for applying and approving deviations if the application needs to. However, after we have implemented Enterprise Puppet in our enterprise, we have automated quite a few of this. All of the processes are now being automated, and we have provided self-service capability to the users for the fixing of the drift and for the deviation management. So for the next few slides, I will be concentrating on the three processes, which are reporting, fixing of drifts, and the deviation management. So for securities reporting, we have provided users the capability to generate and manage and aggregate their own data using a self-service portal. So what we have done is actually take whatever the Puppet data into the Puppet database through the scanning, and on one-off, offload it from the Puppet database and put it in our marketplace database. This allows us to actually carve out report templates and fill it with the data that has been scanned by the Puppet agent on each of the servers. These report templates then generates on-demand report for the users to view. For the fixing of the drift, we refer to it as auto-healing, but actually it uses the self-healing capabilities of Puppet. So this provides us an automated reversion of any drifts to the baseline value that has been identified. So how this works is that fact collection are done by the agents in each of the endpoints managed by Puppet through the use of Puppet facts. We also develop our own custom facts for some of the checks which are not available in Puppet. These facts are then compared with the HIRA value and then notify for any deviations or for any drifts based on the baseline value. Once the drift is detected, Puppet agent will actually execute the self-healing capability. So it would either go for a standard value, which is defined through our HIRA, or it will go through a deviated value, which is defined through another file and that has been approved by the security team. Some of the application would require values to be deviated as per the application standards. These deviated values must be approved by the security team, and the application team must ensure that there are proper controls to this deviation. So how they do it is through, again, the SecureSys, which is a self-service portal for raising these deviations. They log into the marketplace and go to SecureSys and requests for this deviation. This deviation goes through an approval workflow, and the request will be routed both to the application manager and to the security team for approval. Once an approval is given, it will actually trigger a Puppet task in the background. What this task will do is to fetch the deviated info from the report. It will create a host YAML file if not present for the particular endpoint and update that host YAML file with the key value pair of the deviated policy and the value corresponding to it. After it has been updated, all of these updates will trigger a file sync on all compile masters. So what it means is that every after run of the agent scan, when the agent tries to perform self-healing, it will actually refer to the host YAML file for the deviated value instead of the baseline value. And that will update the record also in our application. With this and the rest of the application in a technology marketplace, we're able to scale our DevOps capabilities. One of the task analyses have already reduced 100,000 toil hours. We have also seen faster turnaround times. From days, tasks are being executed instantaneously, and components and services are delivered within minutes. Users don't need to scramble and look for these services across different portals, they can all view these products and services using a single pane of glass, which is the technology marketplace. Since we have automated a lot of these tasks, security and conformance are at its highest. So we are seeing less and less deviations and less drifts in the application servers. SMEs are now having focused delivery, having to think only on how to improve backend services without thinking of developing any front-end applications for their service offerings. All in all, it provides joyful user experience for both dev and ops. Thank you for listening to our talk and hope you have a great day.
Thank you.